Hello everyone. In this video, we're going to discuss Codeforces 669 Div.2 Discrete Centrifugal Jumps problem. So basically, what we have in this problem is we have n beautiful skyscrapers which have heights HIs from 1 to n, and we have to jump from the first one skyscraper to the last skyscraper with the following conditions to satisfy for any jump: whether we can jump next to each other. If there is a next skyscraper, we can jump to it. Otherwise, all the skyscrapers which we will avoid jumping to and jump to the next one is strictly their maximum height should be strictly less than the minimum height of the first and the last skyscraper. First and last here refers to the from and to, and the maximum height of or the other condition can also be like the minimum of all the HIs which are middle. Like it means like we can have two conditions, like I can write here, like whether we can jump from this skyscraper to this skyscraper, and all the skyscraper in the middle are just smaller than this. Or we can have the other condition, and the first condition is just we can jump from here to the next one, and the last condition or the other condition is we can jump from here and all the skyscraper in the middle are strictly greater than the end skyscrapers. So how we will do this problem? So if we try to do this by greedy, it won't work. The one example that I have taken here is this one. We have a height array 3, 1, 2, 3, 4, 5, 6, 1. So if we go greedily, we will jump from 3 and then we will avoid 1, which is less, 2 is also less, 3 is not less, it's equal. So we'll jump from 3 to 3 in 1, and then we will have to jump to 4 because it's not like because like we can jump to the next one, and also then 5. So it means to go to 5 from 3 you have to jump from 3 to 4 and then 4 to 5. Like I can draw like this. Like if you jump 3 to 3, then you have to jump the next one 3 to 4, and then the 4 to 5, and then 5 to 6, and then 6 to 1, which will end up you to have 5 jumps. Whereas if you jump to 3 to 1, and then you will see 2 is greater than, 3 is also greater than, 4 is also greater, 5 is also greater, and 6 is also greater. So then you can jump directly to 1 in just 2 moves. So this problem is actually a dynamic programming problem. So dp of I represents the minimum number of moves to reach position I. So in the beginning we are at position 0. So the dp of 0 will be 0, because we have not done any jumps, and these are the minimum number of jumps required to reach the position 0. And dp of, now how the transitions will take place. So if if we have to calculate dp of, let us say, okay, just a minute. So dp of each next position which is possible, dp of I plus 1 will be it will be dp of minimum of, we will initially fill the dp array with a infinite value or a large value. Say even we can fill that with n, because the minimum number of steps will always, maximum number of steps will always be n minus 1. So we can fill them n because it's not possible. So dp of I plus 1 will be minimum of dp of I plus 1. This is terrible to write. comma dp of the previous step, because you can always jump from the previous to the next. So dp of I will be initially dp of I plus 1, because this is always n or the big value, so this will always be dp of I plus 1. But now what we will do, we will gonna do here two things. So what those two things will be, because we have seen that we can avoid the greater element and we can also avoid the lesser element. So what we will do, we will at each for each position, like for example here 1 2 3 4 5 6 7, for each of these heights we can track that what can be the minimum cost of jumps we can have if we jump from the last position, which can be not just the previous one, like for example in this case of 3, it need not to be 2, it can also be 1 and it can also be 3. So we end up like we having this, we can jump from the initial one, so we will keep track of these things. So what we will do, we will keep two stacks. Let us say this is stack 1 and let us say this is stack 2. So initially we will put the 0th element in the stack, or the 0th index in the stack. So we'll initialize the stack with the 0th element in it, and then as we move on, so like for example 1, we will insert each element in the stack, and then we will also keep track of that whether, like for example this 1 is strictly less than 3. So we will compare the heights of the elements, last element and of the stack and the current element, and we will check if this is less than equal to or greater than equal to. If this is say less than equal to, so we can put in one stack, and if it is greater than equal, if it is less than equal to, so we will then compare I mean, just a minute, I need to explain here that, I mean, what we can do, we for example when we reach any position I, so then we will check the earlier elements like 2 1, that well they are strictly less than that or strictly greater than that, because we can avoid always these cases 3 1 2 3 or and 3 4 5 3, we can always jump from 3 to 3 in both of the cases. So we will using the stack of the element which is strictly greater than and which is strictly less than, we will come to know that this is the last position from where we can jump to here. And since this is the last position from where here we can jump to here, so the dp value of here will be the minimum of dp of I comma I minus 1 comma plus 1, and also the dp of the last position plus 1, because you can also have jump from the last position to this position and add one more step, or you can also jump from the last from the next from the last previous element, like in this case is 2, and then jump to the next one. So I hope you like, and in these two stacks we will just keep track that whether the element is less than or less than equal to or greater than equal to. And so like let us just see the code to understand it a little bit more. So I can erase here. Oh, just a minute. Yeah, erase this one as well. Okay, so here we initially input the array, and then we will keep a dp array with the maximum value, which indicates the minimum number of steps to reach the position I, and we will initialize it with n, because at the maximum n minus 1 steps are possible, so n is never possible. So just this is, you can also put it infinity. And then the dp of 0 is 0, because there is no move required to reach the position 0, and it is the minimum move. Then we keep two vectors or stacks. We insert 0 in the vector, and then at every position the dp of I is dp of I minus 1 plus 1, that you can always reach from the last element. and then if the stack is not empty and the element height is strictly greater than equal to then what we will do, we will check whether the height is strictly greater and the stack is still not empty. It indicates that there are more than two elements initially in the stack, because if there is one element, then this is the same condition, this condition. So this condition ensures that if there are more than two elements initially in the stack, then we can say that because the element is strictly greater, we can avoid this element. Why to jump from this element which is strictly greater than or strictly less than in this case? So then we will, in this way, initialize. We will just make the dp of I, the minimum of the dp of I, which will come from here, the last position, or the last to last position from where it can jump, plus 1. So whatever is the minimum, we will take that, and then what will be the answer will be the minimum number of steps to reach position n minus 1. I know I have just made a lot of maths to explain this, but just it's a discussion. It's, don't take this as a tutorial. And so I hope everyone likes it. Thanks everybody.